Hi, we are the future inventors. Meet our team members. Sophia Laganis from Canada, Mavea Graham from Canada, Azarel Christopher from Indonesia, Elliot Ledringdale from Sweden, Mohammed Farhan Alam from Bangladesh, and Santiago Luna from Mexico. Now I request my teammate Mavaya to present.
Next, please. So what is the problem or issue? Drinking water contamination and poisoning is a severe issue impacting humanity and nature globally due to our insensitive and inconsiderate actions that we take part in on a daily basis. Due to our diminutive efforts, these contaminants and poisons end up in the water we drink, and for many countries, their only source of water. Our health becomes a factor to play, and after indulging in noxious water, we start to develop health issues. In grievous cases, death is the woeful outcome. As mankind, we need to step up and do something about this problem. I would like to request Azrael to present the next slide.
What is being done now by communities, the World Health Organization, the government, and the people? Many communities have been cleaning up the environment together, and the World Health Organization is binding laws against lead paint. The government of Bangladesh is still trying to improve rainwater reserving infrastructure. Meanwhile, most people are still acting as if this problem does not exist. If this problem were to be ignored, life on Earth will surely perish, as water is the most important thing living beings need to survive. Next.
Our team's proposed solution is called the plasma water purifier. It's a technology that's very recent discovered. Accelerating water at high speed converts it into a liquid gas mixture. An electrical discharge from an AC power source is applied to the water through high voltage electrodes and turns it into a plasma. When the mixture slows down, it turns back into a liquid. This creates clean water without a significant rise in temperature. When plasma comes into contact with water, it generates a host of reactive radicals such as hydroxide, oxygen, hydrogen peroxide, and ozone. These will attack the contaminants in the solution. The resulting end products are essentially harmless. Our objective of the solution is to first the water purification without using any chemicals, and the replacements of the chlorination for disinfection, more effective and efficient than current water treatments, prevention of harmful disinfection byproducts. So you might wonder what happens inside the plasma water purifier. First, there's advanced oxidation. Secondly, ultraviolet disinfection. Thirdly, ozonation. And last but not least, hydrogen peroxide disinfection. Next slide.
So we can implement our solution in two ways. One is large-scale implementation in water purification plants, where we will use our solution as the tertiary water treatment process to replace chlorination in order to eliminate all the health hazards of using chlorine in drinking water. The second is small-scale implementation in household wastewater purification, where we will use the plasma water purifier as the final stage of wastewater purification. To conserve energy, we will install in-pipe water turbines that will use the flow of water inside pipes to generate electricity. One policy is needed, and that is government can make it a policy to install wastewater purification units in every house. So the first step that we need to take is we have to start manufacturing plasma water purification units and wastewater purification units. And the second step is we have to replace chlorination with this technology and start installing wastewater purification units on our houses. Now I request my teammate Sophia to present the last slide.
Impacts. The impacts of our solution can be split into three categories: environmental, social, and economical. In environmental impacts, we have the recycling and conservation of water and the elimination of harmful emissions. For social impacts, we have easier accessibility for clean drinking water and the eradication of waterborne diseases. Lastly, for the economical impacts, we have the financial benefits for the country and government. and more job opportunities. Thank you.
Okay, any questions?
Okay, from me, uh, what is the difference between the plasma water purification that you mentioned with the common one that we already have?
Farhan, would you like to answer that?
Sorry.
The difference is that when the common one is chlorination, use of chlorination to kill all the bacteria and viruses. But chlorine is a chemical and it has other health effects on our body. But if we use this solution, like the plasma water purifier, we are not using any other chemicals, just it's purifying the water using electrical discharge. So there is no use of other chemicals. That means there is no side effect on our body.
Okay. Okay, and it will purify many times with the filter like UV and others.
Yes, there are many processes going on inside the plasma water purifier.
Yes, good answer. Thank you.
How much does it cost to produce one system for a house?
We haven't thought of the cost, but it's a little bit expensive.
Do you have any idea how expensive is expensive? Is it $1,000, $1 million, $1 billion?
I'm guessing
It will never be it will never be $1 million. Maximum $5,000.
Oh, okay. There is a question. Where do you see this project in 5 years?
In 5 years, I see that many water treatment plants will adapt our solution, and I see that in many places there is no waterborne diseases at all.
Okay. Anyone else?
I see that maybe we can start to implement these in households, and that big companies will start to be looking at this issue and looking at our solution and finding ways to implement it in the different forms that we have explained in our presentation.
Very good. Okay, excellent. Thank you very much. You did a great job. Thank you. Congratulations. Congratulations.